Okay, listen here, all of you. Today we are going to discuss about that open circuit and load characteristics of self-exited DC shunt generator. See here, that is the motor and the generator. Here, the motor, it is the DC shunt motor. It is mechanically coupled with the DC shunt generator. So you are after the power generation. Okay, DC generator, we are performance we need to monitor. So it was connected mechanically. So initially, as per the circuit diagram, you have to give the connections. That is the 230 volt DC supply we have, positive and negative. So for the measurement purpose, the voltmeter and the ammeter and the 3-point starter and field rheostat. So as per the circuit diagram, you need to give the connection. This is the field rheostat. Okay. Then this is also the field rheostat for the generator. Then this is the 3-point starter. Hey, come on, focus here. This is the 3-point starter. Here the terminal L, F and A. Okay, this is the input supply. So parallelly you can connect to the voltmeter, and this is the circuit breaker. Instead of the DPS switch, we are directly added the circuit breaker. So once if you are started the circuit breaker, immediately we can see the voltage, the present voltage. So because here now we are the starter we are not on, so the voltage was not showing here. So you have to run the 3-point starter. Through the 3-point starter, you have to start the machine first. Come on it. Wait. Yeah, now we are given the supply. Then you can start the DC shunt motor through the 3-point starter. Start it. Yeah, once it is getting started, we can see the voltage. But here, here we are connected the voltmeter in the secondary side because we need to monitor the performance in the generator. Okay, so we need to the motor is getting started. So that is the field rheostat. So you have to adjust and fix the rated speed of the DC shunt motor. So you can adjust it and you can fix the speed 1500 RPM. So it was the minimum position. We are adjust, and now the speed is we are testing. Yeah, now the speed is 1500. The rated speed was we are fixed. Then it is the self-exited DC generator, right? The self-exited DC generator, here the field excitation, once we are giving the field excitation, then only the supply is getting out, the power is getting generated. So it is the minimum position. So while you are doing the no load test, you have to gradually vary the field rheostat, and simultaneously you measure the ammeter reading as well as the voltmeter reading. Once the power is getting generated, in the same time the field current is 0 to 2 ampere, right? So once if you are applying the field current from the minimum position to maximum position, the field current also getting increased from 0.1 to 0.7, right? So parallelly 0.1, 0.2, 0.3, 0.4 up to 0.7, we can adjust the rheostat through the corresponding generated voltage. We also measure. That is the open circuit test. Okay, the open circuit test. So the reading we are noted. So we can measure it. So that was the open circuit test. So up to the 0.7 gradually we are varying, and parallelly the voltmeter also, you can see that voltmeter also getting increased. Okay, while you are varying the rheostat, the voltmeter it is getting increased. It means that it is started the generation while we are applying the field voltage. Okay, so you can fix the rated voltage. The rated voltage is 230. So you can adjust and you can fix it. The rated voltage, that is the 230. So now that we are done the open circuit test, the gradually 0.1, 0.2, 0.3 up to 0.7 we applied. The parallelly the voltage, the rated voltage we measured. The rated voltage is 230. So the 230 we obtained. That was the open circuit test. Okay, up to this, that is open circuit test has been finished. So this is the load side. Okay, that is the generated voltage. That is here it is. We are seeing the generated voltage. That is the ammeter reading. That is for measuring the load current. So that was the DPS switch. We are applying the load. So we can close it first. Then we are start applying the load. That was the main. You can on it. Yeah. Then the rated current, up to the rated current you can apply the load. Here the rated current of the generator was 10 ampere. So you can apply 1 by 1. 2 ampere, you can apply the 2 ampere load, and parallel you can measure the reading of ammeter. You see that 2 ampere load was applied. Here the reading was 1.9 is came. Similarly the voltage, similarly the field current also getting reduced. So here all the readings has been noted. Similarly you can apply the another one load. Yeah, that also we are noted. You can apply another load up to 10 ampere. You can apply the load. Yeah, the corresponding reading has been noted. Then you can remove the load one by one. Remove it. Yeah, you can remove all the loads. Then you can remove the main also. So then again you can open the DPH switch like that. Then the next one, the field rheostat, that is the generated field excitation. The field rheostat you should bring minimum position. Bring it. You bring it minimum position. So while you are bringing down, you can see that current and voltage also getting reduced. Okay, while you are applying, the voltage has been generated. That is the field excitation. Similarly, the field rheostat, that is the motor field rheostat. Here that is the mechanical coupling. So that this is the rated speed was 1500 rpm. So that we are initially it was the minimum position. So now we are fixed the 1500 rpm. So we need to minimize this also. Minimize it. Then you can remove the supply. Remove the supply by using the circuit breaker. Yeah, the 3-point starter, it automatically coming down while you are removing the input supply. The starter it is getting automatically off. Okay, this is the load test for the load test and as well as open circuit and load characteristics of DC shunt generator. Okay, here it may operate two different mode. That is the self excitation. Now we have done the experiment for self. Similarly, separately means we need to give the supply. This is alone only different. You see here, this two terminal. This means the rheostat 2 terminal, we are taken the field current from generated supply. That is why the name is called self excitation. If you are given this supply, that is the field excitation, you are given differently or sorry separately. That is the separately excited DC shunt generator. Okay, we have done this same circuit diagram. Only these things are different. Both the self as well as separately excited DC shunt generator. Through this experiment, we can find the efficiency of the generator. While we are applying here we are applying the resistive load up to the rated current. We are applying the load performance. We are load performance curve and performance characteristics we need to analyze after manufacturing of the generator. We can't straight away send to the market. We can't straight away send to the market because we need to verify all the things. So that particular test it may be useful for the quality checking purpose of the manufacturing sector. Okay, thank you.